Good evening, everyone. Welcome to the 102nd lecture on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school for the IBDP courses. And today we will be viewing a video on, just a moment, why is it not been showing? Just give me a moment. Okay. Right. I'm just sharing my screen. Just give me a moment. Okay, so today we'll be viewing a video on forces, which is forces on an inclined plane. Basically, for all those who are new watching this video, this is just an introduction to them also. My video will focus on three parts. The first one is about the numerical. I'll be discussing about what is this numerical about, what is that, what are the inputs given, and what is that you need to find out. So by the time I keep on narrating all this, you can look at the numerical and you can start working on it and see whether you get it correctly or incorrectly. You can keep it aside. Usually the videos will be around the 10 to 15 minute slot, and then duration. And then the second part would be what is the response given by a student. Definitely the response given by a student would be incorrect. I have taken only such kinds of responses. Okay, where most of the students commit the mistake, and we need to ask why they have committed the mistake. Is it because they have not understood the concept correctly? They have applied the concept incorrectly. So what I do is I look at it and then understand, though they have understood the concept correctly, but they have not applied it in a regular or in a correct context. Okay, so that's where the mistake has happened, and then I explain about where this concept should have been applied and they have applied it in a wrong way, and finally I give the correct solution. So these are the three parts that we have. Okay, so now let us move on. If you want to view all my 101 videos, you can visit my website, which is ratankar.com. Okay, so all these videos have been structurally being put across. In fact, this video will also be there, so you can have a look at it. Okay, so now we have a question here. A block slides on the track shown below. Comment on its speed and acceleration in the direction of the motion. Ignore any friction on the track. So usually when we have questions like this, so we have learned already a question like this. You had an inclined plane. You had an inclined plane like this, which makes an angle theta. And you keep the object over here of mass m. Now the answer that we have here is that, okay, first what we do is we put the weight mg like this. And then we put a normal force acting like this. And then we write mg cos theta in this direction. And we also write mg sin theta in this direction, which is nothing but your free body diagram. And then if I ask you what is the force acting on this object down the plane, what is the force at this point? Mg sin theta. What is the force when it is midway? Mg sin theta. What is the force when it acts here? Mg sin theta. Okay, so therefore the net force or the force that acts on the object at any position during its travel is always equal to mg sin theta. That's what you can say. And as a result of this, now what we do is we can now say the acceleration, because you see, comment on speed and acceleration. That's what is given. The acceleration here is nothing but mg sin theta divided by m, which should be equal to g sin theta. Theta is constant, g is constant, so definitely acceleration is constant. And hence you can say it experiences a constant acceleration. Some of the students have given me this answer also. The moment they read this, okay, block slides down the track shown below, and they think that this is nothing but an inclined plane like this. Okay, that idea immediately creeps into, and they think, yes, this is what it should be, and hence the acceleration should be a constant. So the answer they had given is that since acceleration is constant, speed should increase, and acceleration is constant. So this is one of the answers I got. The second answer is interesting. Second answer says this block is sliding down. See, it's sliding here, it is sliding here, it is sliding here, everywhere it is sliding down. The speed and the acceleration should be increasing. Okay, this they have thought might be because it's sliding like this, and every time, okay, this curve has been increasing like this. Could be that acceleration is also increasing. There is no reason for this. At least I can say there's a reason here. Okay, but here there is no reason at all. So what has happened here? a concept which is nothing but a free body diagram, application of free body diagram, which was applied in the inclined plane, has now been used even in this situation. Now, what is the difference between the inclined plane and this plane? Let us ask that question also. The difference here is that, see, everywhere, if I draw a horizontal line here, 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 and I say, what is my angle here? The angle at every point is one and the same, right? But if you look at, if I do the same experiment here also, see, I draw a line here, draw a line here, draw a line in this region, draw a line over here. Or maybe I take this value. What is this angle? This angle is theta 1. This angle, see, this part is linear, okay? Theta 2. Here, almost it's a straight line, right? I can say theta 2 once again. Let us consider this angle. Well, what will this angle be? This will be theta 3, definitely not theta 2. Now we need to ask the question, see, because acceleration equal to g sine theta, acceleration is not constant because theta 1, theta 2, theta 3 are totally different over here. Okay. Now, but we need to quantify it. Okay. So whether it increases, decreases, we need to know that. We are going to use the same equation, no changes in the equation. Okay. So now what we do is, let us find out what is this angle. So here what happens? This is my angle. Now you see, it goes down like this. So as a result of it, what do you comment from theta 1 and theta 2? You see, theta 2 is more steeper as compared to theta 1. Can we say that theta 2 is greater than theta 1? When you say that, then definitely g sine theta 2 is greater than g sine theta 1, which means that A2 is greater than A1. This is A. A2 is greater than A1, which means the acceleration in this region, let me call this region as 2, is larger than the acceleration here. Is larger than the acceleration here. Now let us consider this case. Now here what's happened? See, this is a line over here. It goes like this. This is small acute angle here. Okay. So definitely this is theta 3 is much lesser than theta 2. Theta 3 is lesser than theta 2, which means that sine theta 3 is less than sine theta 2, which means that g sine theta 3 is less than g sine theta 2. Right? So which means what? Which means A3 is less than A2. A3 is less than A2. So thus, now we can say that A2, see, initially the acceleration is low in this region. Let me call this region as third region. Now I can say the acceleration here is very low, and then it becomes higher, and then it again becomes lower, right? So acceleration is lower, higher, and then lower. So it is not going to be uniform. Now correspondingly, when the acceleration is lower over here, speed increases, right? You need to look at the speed over here. Okay, speed increases. Now, how do you write the speed here? Because you see, acceleration here is a constant. If I approximate this curved line by straight line, acceleration is a constant. So as a result of this, we can now write v1 square is equal to u1 square plus 2a s1. What is s1? This straight line that I have approximated is my s1. Okay, so u1 square. What is u1 square? I did not give any speed. I just touched it and started moving. So therefore u1 becomes 0. This becomes 2a s1 over here. Okay, so I get the value of a1. I'll write this as a1 here. I'll write this as v1 square divided by 2s1 is equal to a1. That's what I got. I got an acceleration here. I use my equations of motion. Now when it comes here, what is the velocity at this point? Velocity here, v1 is equal to square root of 2a s1. Here, what was the velocity? It was 0. When it comes in this region, what's the velocity? Velocity is really higher than 0. It is not 0 here, right? It's moving at a larger velocity. So as it starts sliding here, what is the velocity in this region? Velocity is very, very high, right? Velocity here is v2 square is equal to v1 square plus 2a s2. See, this is the region s2. So therefore, v1 square is the velocity here, initial velocity. And thus, this is the velocity here. I can substitute if you want. I can substitute this and get the answer. That's not my interest over here. So the velocity here is much larger than v1 here. Okay, so let me write down. In this region, it was v1. And when it comes here, it is v2. Here it is v2. And here it was the end of this region gave you v1. Here it is v2. Okay, when it reaches here, it is v2 here. It is v2, not here, sorry. This is v2 here. When it reaches here, is there a break? There's no break, right? So which means what? Okay, either the particle can continue with the same speed. If it was a plane surface, it will continue with the same speed. Or its velocity will increase. When will it increase? When there is someone to increase its speed. Who increases the speed? Acceleration increases the speed. Is there an acceleration or retardation here? There is an acceleration. How come there is an acceleration? There is a g sine theta here, a3. However small this could be, but still it will increase it, right? So therefore, the velocity at this point could be v3. Now, from all these logical conclusions, what do you understand? You can say that v3 is greater than v2 is greater than v1. First thing, that means the speed of the particle keeps on increasing as the particle starts sliding down. First thing. And secondly, acceleration. What happens to acceleration? Acceleration here is lesser, then it becomes higher, and suddenly it becomes lower. I hope, okay, you have understood the concept behind it. These kinds of questions are extremely important, okay, in competitive examinations, because you see, there's not much of text. Usually, when you have a question which does not have much of text and only one image, you have to be very careful. There's a lot of information hidden there. You need to understand it part by part. Okay, no equation, nothing is given, but you need to analyze it a lot. Thank you, friends, for watching this video. So if you really like this video, do share, comment, and subscribe to my channel for more updates. Thank you.